Hello everyone, welcome back once again to the Mickey Mouse class. Alright, we'll be continuing our series of differentiation. And in our last class we said that differentiation gives the gradient of a point. So for us to find the gradient of the point, we differentiate. Now let's look at this question. This is given that y is equals to the cube root of x squared plus x. Find the gradient when x is equals to 8. Now the first thing we are asked to do, you have y equals to the cube root of x squared plus x. The first thing we have to do is to differentiate this function. And after we have differentiated it, wherever we see x, we impute it, the value of x, into what we have differentiated. Now this becomes, let's arrange it before we differentiate. Y will be equals to cube root means raised to the power of 1 over 3. That means this is x squared raised to the power of 1 over 3 plus x. Now 2, from our indices, index law, when you have a power raised to another power, you multiply them. So this 2 times 1 over 3 becomes x is to the power of 2 over 3 plus x. Now let's differentiate. Our dy over dx will be equals to, remember, multiply and take away. 2 over 3 times the coefficient here is 1 will become 2 over 3 times x. You have 2 over 3 minus 1. That's negative 1 over 2. For those that don't know what I did, 2 over 3 minus 1. This is 3. Change this to equivalent fraction of what you have here. It will be 2 over 3 minus 3 over 3. 2 minus 3, that's negative 1 over 3. Negative 1 over 3 plus, when you differentiate x, you get 1 plus 1. So having differentiated that, now let's so our dy over dx is equals to 2 over 3 times, this is the same thing as saying times the cube root 1 over, since this is negative 1 over 3, so 1 over the cube root of x plus 1. So let's impute the value. So the gradient when x is equals to 8, wherever we see x, let's put 8. So this becomes 2 times 1 over 3 over cube root of 8 plus 1. So what's that number that you multiply 3 times to get 8? That's 2. 2 times 2, 4 times 2, 8. So the cube root of 8 is 2. So this becomes 2 over 3 times 1 over 2 plus 1. 2 here, 1, 2 here, 1. So I'm left with 1 over 3 plus 1. Now, the same equivalent fraction. This is 3, or you can find the LCM, whatever works for you. So this, I can say 1 over 3. 1 is the same thing as saying 3 over 3. 3 over 3, that's 4 over 3. So the gradient when x is equals to 8 of this function is 4 over 3. Alright, let's look at another question. This question says, find the coordinates of the point where the gradient is equals to 0. Y equals to 1 over 3 x is to the power 3 minus x is to the power 2 minus 3x plus 4. The first thing we do, we'll differentiate this function. And the answer we get when we have differentiated, we set it to be equals to 0 to get our x. And if you have gotten the x, or the value of x is, for the value of x is, bring it back to this equation or function and put it to get y, because the coordinates means the x and the y-axis. So the first thing we do, if our y is equals to this, so our dy over dx will be equals to this times this, that's 1, x, 3 minus 1, that's 2, x is to the power 2, minus 2 times 1, that's minus what? Minus 2, x raised to the power 1, 2 minus 1. We always subtract 1 from the power. Now this becomes minus, when you differentiate this, you have minus 3, and when you differentiate the constant, you have 0. Now the next thing, because we said find the coordinates when the gradient dy over dx is 0, so set this to be equals to 0. So 0 is equals to x squared minus 2x minus 3. This is a quadratic equation, so let's solve it. This times this, put it in one corner, minus 3x squared. Now what are the two numbers that will multiply to give you minus 3x squared? And when I add them, I will get what is in the middle. That will give us 3x minus 3x and 1x. Those are the two factors. If I multiply these two numbers, two factors, I'll get this. If I add them, I'll get what is here. So replace minus 2s by this. So this becomes x squared plus x minus 3x minus 3, factorized by grouping them. So this becomes x into bracket x plus 1 minus 3 into bracket x plus 1. So the two factors are x minus 3, x plus 1 is equals to 0. So from here, our x is equals to 3 or negative 1. When you solve this, x minus 3 equals to 0, x will become 3. X plus 1 equals to 0, x will become 1, negative 1. So having found the value of the x coordinate, let's impute it into this to get our y, and that's the end of the question. So we have that our y is equals to, so when x is 3, let's impute it. So this becomes 1 over 3 into bracket 3 raised to the power of 3 minus 3 squared minus 3 into bracket 3 plus 4. So 3 raised to the power of 3, that's 27. That's 27. That's 1 over 3 times 27 minus 3 squared is 9. 3 times 3, 9 plus 4. 3 here 1, 3 here 9. So 9 minus 9, that's 0. 0 minus 9, that's what? Minus negative 9. So negative 9 plus 4, we have negative 5. So our y, that's the y for when x is 3. Now let's put it when x is negative 1. What do we get? So y will be equals to 1 over 3 negative 1 raised to the power of 3 minus negative 1 raised to the power of 2 minus 3 into bracket negative 1 plus 4. Now negative 1 in 3 places will give us negative 1. So we have negative 1 over 3. Negative 1 times negative 1, that's square, that will be 1. Times this, we have negative 1. This times this, we have plus 3 plus 4. Now, from here, 4 plus 3, that's 7. 7 minus 1, that's 6. So you have negative 1 over 3 plus 6. Now look for the LCM, that's 3. 3 in 3, 1. Times this, negative 1 plus 1 in 3, 3. 3 times 6, that's 18. That's what? 17 over 3. So we have found the value. So the coordinates of the point, the coordinates will be when x is 3, y will be what? Negative 5. So these are the coordinates. These are how you represent your final answer. When x is negative 1, y will be equals to 17 over 3. So this is the answer. This is the coordinates of the point where the gradient is 0 of this function. 3 and negative 5, negative 1 and 17 over 3.